All right, welcome to the Explainer. Today, we're going to put together the ultimate study guide for a super important part of the internet, the transport layer. And by the end of this, I promise you'll have a rock-solid handle on TCP, UDP, and sockets. So here's our game plan. We'll start with a simple way to think about it, the internet's mailroom, then we'll meet the two main protocols, check out the big debate between reliability and speed, see how programs actually talk to each other, and then we'll wrap it all up with a quick study guide. First things first, let's talk about the internet's mailroom. This is just a really great way to get a handle on what the transport layer's job really is. Okay, for anyone taking notes, this is the official definition you'll want. The transport layer is layer 4 in that big OSI model, and its main gig is what we call process-to-process delivery. Now, what does that mean? It means it doesn't just get a message to the right computer, it gets it to the right application running on that computer. Think your browser, a game, Spotify, whatever it is. And this mailroom idea really makes it click. You know, a giant office building has one main street address. That's kind of like your computer's IP address. But the transport layer is the mail clerk inside. They don't just dump all the packages at the front door. Nope. They look at the specific department number on the label, that's the port number, to make sure that package gets to the right desk. So what does our trusty mailroom clerk actually do all day? Well, a bunch of absolutely crucial stuff. It chops up big messages into smaller packets and then pieces them back together on the other side. It handles that all-important addressing. It even acts like a traffic cop, controlling the flow of data so things don't get overwhelmed. Oh, and it checks for mistakes and basically manages the entire conversation from start to finish. Okay, so we get the mailroom's job. Now let's meet the two main delivery services it uses to get the job done. You've probably heard of them, TCP and UDP. First up is TCP, the Transmission Control Protocol. This is your certified mail service. It's what we call connection-oriented, which is a fancy way of saying it establishes a formal connection, kind of like a handshake, before it sends anything. It is all about one thing, reliability. It guarantees every single piece of data gets there in the right order and with no errors. So, when do you need that level of perfection? Well, pretty much anytime you can't afford to lose even a tiny piece of information. When you're loading a web page, you need all the text and images, right? When you're sending an email, it has to be the whole email. Downloading a file, same deal. That's all TCP. And then you've got the other option, UDP, the User Datagram Protocol. Now, if TCP is certified mail, UDP is like scribbling a note on a postcard and just tossing it in the mailbox. You just send it and hope for the best. It's connectionless, no setup, no handshake. This makes it incredibly fast, but it offers zero guarantees. Data might get lost, it might show up out of order, who knows? So you might be wondering, why on earth would I ever use something so unreliable? Great question. The answer is simple, speed. Sometimes being fast is way more important than being perfect. For live video streaming, fast-paced online gaming, or a voice call, you need the latest data right now. A single dropped frame in a video or a tiny audio blip is much better than the whole thing pausing to buffer. And that right there brings us to the fundamental choice, the big trade-off. This isn't about which one is better. It's about choosing the right tool for the specific job you're trying to do. This table is the perfect cheat sheet. Seriously, if you're studying, take a screenshot of this. TCP is connection-oriented. It's reliable, it checks for errors, but all that work makes it slower. UDP is the total opposite. Connectionless, unreliable, no error checking, but because of that, it is way, way faster. That is the core difference you have to get. Okay, we've got the protocols down, but how do programs, like an actual web browser or a game, how do they use these protocols to talk across the internet? The answer is something called socket programming. A socket is like a digital doorway that an application opens up to the network. It's the endpoint, the exact spot where it sends and receives all of its data. So what is a socket really? It's actually super simple. It's just a combination of two things we already know, the computer's IP address and the application's unique port number. You put those two together and you get a complete, specific address for one program running on one machine anywhere in the world. Now, from the server's point of view, it's kind of like setting up a shop. First, it creates the socket, opening the door. Then it binds it to an address, which is like putting up the sign with its location. Then it just listens, waiting for customers. When a client connects, it accepts them, they do their thing, sending and receiving data, and finally, when they're done, it closes the connection. The client side of things, that's your computer, is much simpler. It's the customer. It also creates a socket, but then it just connects directly to the server's address that it wants to talk to. Once they're connected, they exchange data, and when it's over, the client just closes its end of the line. Easy. All right, we have covered a ton of ground, so let's boil it all down to the absolute essentials you'll want to have locked in for any exam or interview. Here it is, your cheat sheet. Number 1, the transport layer is layer 4 and it does process-to-process delivery. Number 2, TCP equals reliable. Think certified mail for web and email. Number 3, UDP equals fast. Think postcards for streaming and gaming. And finally, number 4, sockets are just an IP address plus a port number, and they're the endpoints programs use to communicate. So, to wrap this all up, let's apply it. If you were in charge of building the next big video sharing app like TikTok, what would you choose? Would you go for TCP's rock-solid reliability to make sure every single video frame is perfect? Or would you pick UDP's blazing speed to keep that feed scrolling smoothly, no matter what? Kind of makes you think, right? Thanks for joining this explainer.